In this video, we're going to explore how we use CodeApp to get ourselves set up. And I'm going to show you a couple of the key tips and tricks to make sure that you're doing everything right. So first of all, you should be able to see on your screen the address. We're going to codeapp.concord.org. Make sure you spell that right. I would bookmark that page because we're going to be going here quite frequently over the next few weeks. And probably when we do a little bit more statistics at the end of the year, we'll be coming back here for to see some of the other things that it can do. So this is CodeApp. It is a data analysis software. It is web-based, so you can use it on any device, anywhere in the world. One of the things that I really like about this system is it is designed not just to do robust statistics, but also it's got a real education focus as well. So we're learning about the statistics while we're actually doing it. We don't have this massive learning curve that you have with other pieces of software, where that actually becomes a barrier to your learning. So we're here at CodeApp. We are going to launch CodeApp. You'll see this dashboard. It will come up, and we've got a couple of options here. The very first thing that I do want to point out here is when you save your work, and I will strongly encourage you to do that. When you save your work, if you download the file to your computer can't open it. So what that means is to open a CodeApp dashboard, you need to go into CodeApp, you need to start it up like we just did, and then you open a document. So I'm going to open up a file, so I'm selecting a file, and I'm going into my downloads. So in my downloads folder, I can see that I've got a CodeApp document. I open that one up, and we can see that we've got some data there. What I'd like to do is show you how to create a new document and some of the tips and tricks to make sure that we're doing this right. Now, if you are in our mathematics page, we are in the topic bivariate data. You can see two files here, one called datasets, one called statistics correlation handout. Both of these are really important. If you download the datasets file, this is where we're going to start. You'll get to this spreadsheet here. Now, this spreadsheet is got some data that we're going to play with a little bit later on in the year, but the census at school data, if you click down the bottom, you'll see a nice little table with some variables and some data and some everything else. This is from about 10 years ago or so. The Bureau of Statistics did a project with schools. Students inputted data into the census at school system, and so this is all student reported data. Anytime we are collecting data, we do need to be careful about is it reliable? Is it valid data? And so we'll see that in a minute. So just highlighting the data, I'm copying it. Right, I press Control C, and we get the answer around the outside. Otherwise, I can do a right click and copy. We're going to go into our document, and I'm going to create a new table from the clipboard. Right, when I copy data, it goes onto the clipboard. If I go new from clipboard, all of that data has now come across. Now, when I look at this data, it is really important to just sort of have a look and make sure that everything seems kind of reasonable. I'm kind of looking at some of these arm spans here, and this arm span of 10 centimeters just doesn't seem quite right. An arm span is when you hold your hands out, as far away as you can. It's the length from fingertip to fingertip. Someone who's 157 centimeters tall will not have an arm span of 10 centimeters. That to me seems like maybe it is an inaccurate value. If we can justify that a piece of data is inaccurate, right, it seems totally unreasonable, then we can delete that value. So I've just double clicked and I press delete and then enter, and that value is now gone. It won't appear. Okay, I'm also looking at the sleep value for this person. They're apparently getting 16 hours of sleep. That doesn't seem entirely reasonable either. I mean, that means that they'd be going home from school, getting to sleep, and then waking up in time for school. That's probably not not a reasonable value, probably not a typical value for this person. So I'm going to delete that value as well. One of the main things that we're going to do with this data is to graph it. So I've just clicked on graph, and you can see that we've got some points just sort of randomly placed here. What we're going to do is we're going to click where it says click here, and we're going to put some variables in. So these variables, in terms of the data that we're working with, we want number values. So we're not going to use gender here. Okay, we could, and perhaps later on we will. What we might do is we might look at the relationship between height. So we'll have a person's height, and you can see that it's now turned into a dot plot. And then on the vertical axis, I'm going to have their arm span. And I'm just going to make it a little bit bigger so that we can see things a little bit more clearly. So we've got some data values here. Looks like there's a couple of values that aren't really in the main trend line, right? All our values sort of seem to have a bit of a relationship through here. This value and this value, maybe they're not entirely, they could be reasonable. We're at the point where it's kind of hard to go, this is wrong. So whether we keep these or delete these is a matter of choice. And, we kind of need to justify that. What we can't do is say that we want our statistics to be better, right? We don't want to improve the relationship between them as being the reason to get rid of these values. If it's genuine data, you got to keep it. I don't know if this is genuine data. I didn't collect it myself. So it could be a mistake, could be a mismeasurement, could be a misunderstanding of what these things are measuring. So I'm going to have a look. Now, if I click on the dot, I can see where it is. Look, I'm going to delete these. Actually, no, I'm going to keep them in there for a minute. Keep them in for a minute. Let's do the mathematical part of what we're doing. So in the ruler here, we've got a bunch of things that we can show. We're going to focus in this unit on the least squares line. Notice how we've now got a yellow box that seems to be saying something about the arm span and the height, and there are some numbers in there. We've also got an R squared value, and that R squared value at the moment is a completely new thing to us. This here is actually the equation of the line of best fit. The equation of the line of best fit in this case is the line through which the points seem to typically go. And the way that that would work, if we were to write it in the same form of our line equations that we did in our last topic, we would be writing our y variable, so y, our arm span, y equals 1.017 times the x variable, so times x. Our x variable is the height, minus 6. Okay, it'll look like what you're seeing on the screen right now. R squared tells us how closely the values, the points are to that line. And you can see that we've got 2 points here that are quite a way away. So I'm going to click on the point that I think is furthest away, and I'm going to remove the arm span from that value, and that is going to remove the point from our data set. Okay, notice how the equation has now changed, and so has the R squared value. R squared is a little bit higher now. Let's also remove this value and see what happens. All right, all of a sudden R squared has jumped up and our equation has changed just a little bit. What we're going to do with this information is just record it for now. Later on, we're going to talk about what these values mean and what these equations mean. One final thing, if you need to enter data in, what you need to do, so this is for manually entering data. You're going to create a table. You're going to select new. We need to label this table in 2 places for what it represents. So if we have a look at our statistics correlation handout and we scroll down to our data, our first data set here is about how quickly cars lose their value. So I'm going to call this new data set cars. I'm going to call the cases cars as well. And that's just going to mean that when I start selecting things, I see the word cars there. We can edit the name of the attribute. So if we go to the screen where I got age in years and selling price in thousands of dollars. So my first attribute is age. To get a second attribute, I click plus, and that is selling price in thousands of dollars. I should put the unit for the age, years. And then we just click the cursor in here for our years, right? We write the first row as the first column, so 8, 7, 13, etc. Right, I'm just entering it in and pressing enter. Do the same thing with the selling price. What you will need to do is enter this data in. I know it's a little bit time consuming, but we are going to come back to this data over and over again throughout this topic. So that's Coda. When you're ready to save, just click save here. It'll download to your desktop. You can collect your Google Drive as well, and that means that you will never need to actively save it when you finish. That's personally what I do. So if you have a Google account, feel free to save to there, and then it's going to be a little bit more reliable and robust in terms of the saving of your work. Okay. So that is Codeup. It's a bit of a long introduction, but there's a lot of features in here, and we are definitely going to be doing a lot of playing around with what everything means. All right, look forward to it.